So let's say we're gonna arrange three different dress, which is A, B, and C. So what are the possible arrangement? So basically we make a list first, and then from A, after A, it could go to B and C. From B, it could go to A and C. From C, it could go to A and B. Now, the third one. This can only have one answer from each. A, B, C. A, C, B for the second one. B, A, C, third one. Fourth one, B, C, A. So the fifth one, C, A, B. Last one is C, B, A. So in total, there are 6 different possibilities of arrangement. Then how could we do it not manually by using the concept? Basically, we need to know how many numbers that we're going to arrange. So let's say there are 3 different numbers. That's 3 and put factorial. What does it mean by factorial again? It's basically the number, which is 3, multiply by the next number, which is 1 lower than the previous number. 3 times 2. Then 1 lower than 2, it's 1. Basically that 1 is not necessary, but since I'm going to review, I'll explain everything like that. Then let me tell you the other number. Let's say 4 factorial. So it should be 4 times 3 times 2 times 1, which is 24. Okay. Now, I'm going to continue for the next number. Okay, this is the concept of factorial. As I say, it's multiply the next number 1 lower than the previous number. So 5 factorial, it's 5 times 4 times 3 times 2 times 1. The answer is 120. Now, we're learning more further than basic counting principle, which is permutations and combinations. So, one condition without restriction. What does it mean? So there is no requirements. A doesn't have to sit with B, or the total digit, 4-digit number, cannot be lower than 4,000. It should be a higher. That is with restriction. Now we're gonna talk about without restriction first. So first one is permutations. What does it mean? It's order. So if you want to find the possibilities to arrange people in a race, let's say first place, second place, third place, then you have to choose permutation. Let's say the participants are 6 and you have to choose 3 winners. 3 different winners, so 6p3. Okay, what's the answer from 6p3? You can also check from your calculator, it's 120. Okay, now what's the difference between permutation and combination? Let's see. We want to choose 3 different items from 6 items. So what's the answer? The answer is 20. Why? Combinations is fewer than permutation. How come it becomes like that? Because technically there are, let's say there are 6 different items. The one with red, yellow, green, blue, and orange, and what else? Yellow, green, orange, purple. So we want to pick 3 different items. So let's say the first choice is R, Y, G. This one, if you pick R, Y, G, and then if you mention the other possibilities, which is G, Y, R, these two count it by one thing, because it doesn't matter with the arrangement whether the R come first, then the Y, then the G. It doesn't matter. This considered 1. Even for the other one, which is, let's say, YRG, that's still the same item. Still consists of Y, consists of R, and consists of G. So all these three things considered as 1. While in this part, they're considered as 3 different arrangements. Because of why? Because for the first one, let's say, the red come first. Because we are talking about ordering when we solving permutation problems. So that's why it's different. And combination is lower than permutation if they are having the same number. Okay, now let's move on. The formula for permutation is this: n factorial divided by n minus r. Simple. But combination, you need to do one more additional division, which is divide by r. Okay, that's what you have to do. Now let's continue. With restriction, you have to apply basic counting principle. There are different types of conditions that apply. You can go up to review the concept. Okay, now here I'm going to explain about mathematics books. So there are 2, 4, and 3 different subjects. How do we arrange without any restriction? To do that, 6 plus 3, which is 9. Arranging 9 different books, just 9 factorial. The answer is this. Now, next, 2 mathematics books are not together. So if they are not together, what do we have to do is basically remember that the probability something that will not happen if we add with probability that will happen, the total is 1. What is the meaning of that 1? 1 is basically the whole probability, which is this. The whole probability to choose 9 different books without any restriction. I mean, not choosing, it's ordering. You have to be careful. If it's ordering, we're talking about permutation here. Okay? Now, next, we have to find when the condition of mathematics book are together. If they're together, it means there are 2 ways to arrange that. Either mathematic 1 first or mathematic 2 first. Then multiply with the rest. If we already choose 2, how many books left? There will be 7 books left. So, how many? Now, since there are 7 books, but remember, since you combine this math book together, they're considered as 1. And this 4 and 3, 7. 1 plus 7 become 8. So, you have to multiply with 8 factorial. And the answer, it's gonna be 2 times 8 factorial, which is 80,640. Okay, now let's check the answer on the next page. 80,000. Okay, but don't forget, we need to subtract the whole probability from 9 factorial by that 80,000. So the answer is 282,240. Now, let's see the next question, which is books of the same subject must be placed to one another. So what to do? Now, there are 3 different types of books. First one is mathematics. How many ways to arrange mathematics together? 2 factorial. How many ways to arrange science? 4 factorial. How many ways to arrange literature? 3 factorial. Now, since they have to be arranged by subject, so these are considered as 1. Each of them considered as 1 category. So how do we arrange 3 different category? 3 factorial. It's the same thing basically with the one down here. The difference is just this 2, 4, 3 coming at the last. The 3 factorial comes first. And the answer is 1, 7, 2, 8. Okay? Now, there are different condition. One other condition. If 5 of these 9 books are to be transferred and arranged to another shelf, in how many ways can this be done if the first and the last book of this shelf are literature books? So we need to know how many literature are there. Okay, so there are 3 literature books. Choosing 2. We choose 2 out of 3, so we can do this, which is basically 3. Okay, now how many possibilities to fill in this? 3. Could be literature 1, literature 2, or literature 3. Now let's say literature 1 already put here. Now the only possibilities is literature 3 and 2. Okay, now what do we put here? How many books left? If we already choose 2, then it means 7 books left. Okay, and then how many slots are there? 3. So we pick 3 out of 7. 7 p 3 multiply by 3 and 2. It's the same thing basically. Okay, now next question. A committee of 5 members. So 5 plus 5, 10. From those 10, we select 5. So 10 C5. Simple. Now, a particular couple is in the committee. It means one particular couple. So 2 people are already in the committee. So we need 3 more people. So since 2 people are already there, the total is not 8 anymore. It's become 8. The total is not 10 anymore. It's becoming 8. So we choose 3 out of 8, which is 56. Okay. Now, next page. The other question, which is there are more men than women. So what happened? So we have to make different types of condition because there are 5 men and 5 women there. So what condition that makes it happen? So let's say the women are, let's start with the men. If the men are 1, then the women are 4. So these are not possible. Now if the men are 2 and the woman is 3, this is also not possible. So we start with 3 men, 2 women. Next is 4 men, 1 woman. And last one is the whole male and 0 woman. Now next, we're gonna copy that part, which is here, the same thing. Now, how do we pick 3 men out of 5? Just this. Pick 2 women out of 5. The same thing. Multiply together. Follow the same steps until you get 125 and 1 and add all of them together. You don't multiply it because it's different conditions. Okay? Now, you're gonna do this question below. Question 1 until 10. Okay? And please don't forget to submit it. Okay? Bye.